Okay, but before we get carried away with nice visualizations, let's just quickly top up our dimensions or measures even with some very, very important measures that we need in creating insights. So we want to calculate on-time services, and on-time services will be a simple calculation where we want to count the rows of our stop calls table, okay, close the bracket, and we want to filter everything by the stop calls week. So let's go where the right time flag is actually captured as true, and we're going to close that. Okay, and say hey, and that commits that to there. Another very quick one again, within our stop calls, we want to another measure. Let's look at our punctuality. Okay, so punctuality percentage would be a simple divide. And as you can see there, the arguments come up. What is the numerator? We want to look at the on-time services that we've calculated and relative to our total services. Okay, numerator is next argument, the denominator, else it's just 0. And we want to obviously multiply that by 100 so we get the percentage. I hit enter on my keyboard and I commit that punctuality percentage. I have got my ppm values, that's fine. I've got my cancelled flag in there, which comes with the data set. As you can see, it's not a measure, but I can actually then build a measure from my cancel flag, much like we did with the cancellation rate. Okay, so I'm just going to go stop calls, new measure, and I want to know actual cancelled services. So we're thinking about service reliability here now. Okay, this is just going to be a simple calculation where I want to count the rows of the stop calls data set, of course, and close that bracket again. The next argument will now be the filter. Okay, so we want to do stop calls where the cancelled flag is captured as. Okay, and we're going to close it as okay. And yeah, we'll commit that. So we have our cancelled services. What about reliability? Reliability is a very, very important one. So again, let's look at our reliability. We're just going to create another new measure, and we will calculate reliability as a percentage. Okay, so reliability percentage will be equal to it. Okay, and now we've got numerator and denominator. So we want to see the cancelled services, all right, that we've calculated relative to total services, of course. Else, just go with 0, and we want to close that other bracket. Thank you very much. And we want to multiply that by 100 as well. Okay, we accept that. That's all fine and good. And we're good to go. Again, we've got our average delay minutes. Fantastic. So, you know, one thing to keep in mind in terms of just sort of like understanding VPN versus punctuality, I'm sure we're an industry, punctuality are trains arriving exactly on time, okay, on the basis of the right flag. And BPM is just industry standard. So again, allowing up to 5 minutes delay to 2.5 flag. All right, so let's see punctuality then. So if we wanted to create some visualizations for punctuality, let's come to our punctuality trends tab that we created earlier on. Of course, we've got this initial graph that we put on there. I like to go into the format, general, effects. I like to give it a visual border just because it allows me to demarcate and not create any overlap between different visualizations. So I'm just going to put that over there, and just going to bring in another line chart in here. On the x-axis, basically, I'm just going to select the data dimension in here. Okay, let's go to our dates table, and we're going to select the dates dimension on the for the x-axis just to show me the hierarchy, date hierarchy. I just want the date. Okay, so just give me the date on the x-axis, and then on the y-axis I can plot the punctuality percentage. Right, I can plot the punctuality on the y-axis. I can just drag it from there and just drop it in there, and I've got punctuality as a percentage. Now for some reason this is, so let's show the value as percentage of grand total. Let us show the brand. There's no calculation because The punctuality percentage is a division of on-time services against total services multiplied by 100. So this is interesting. Punctuality percentage 32.49. Interesting. It seems to me the punctuality is for some reason cutting across as a single line. I want something daily. If I went to the date hierarchy and I change that to days, to remove that, remove the quarter, and keep it on days only. Nope, that does not track. Let us go with let's go to service date. There we go. Okay, service date works just fine. Interesting, but there we go. So we use the service date instead. We don't want it showing the date hierarchy, just want the dates. Okay. And we can see basically some sort of pattern there that kind of shows us how punctuality trends are working. We could also maybe in here. Oh yeah, by the way, once you have multiple visualizations on a page, you can select different dates, for instance, or I can select something here, September 2024, and it just tells me, oh, that's about 25th of September, and you can see what the average delay minutes was there, 3.78. Okay, that's the case here. If I want to take it off, I just select that visualization again to turn it off, and everything comes back page. But we'll come back to that. I just want to put a border around this just so I can see it on the screen. So effects, visual border, and box your uncle. Okay, so let's put a gauge. So we can use a gauge here. So again, we can use a gauge and throw in a gauge in there to look at ppm. Okay, so we just take the value that we have here as ppm. So in the value field, we will put our ppm in there, and we are at 85.92%. I think that's not bad at all. And yeah, this could be daily punctuality performance. You could call it as you like. We might want to look at the operator performance. So let's go to our operator performance chart. Again, we had created this earlier on. I can leave that there. And just maybe create another horizontal bar chart, for instance. Let's just go with a standard horizontal bar chart. On the y-axis, I can put the TLC. Okay, TLC. Or I can go to the TLC dimension table and get the actual TLC name and just put that in the y-axis. And on the x-axis, I can put my punctuality percentage in this case. And there you go, we get some sort of sense of punctuality scores for these services. Right, so okay, punctuality percentage. I could always go over here and I can put the data labels on over there just so I kind of have an idea of what is going on. And effects, put the visual border on. I could throw a shadow system to the other one, and like so. So we've got that. Again, I could create a scatter plot, for these insights as well. I could create a scatter plot like so. So that is the scatter chart symbol. And on the x-axis, I can put on the total services. Okay, so I can have the total services on the x-axis. I can have punctuality percentage on the y-axis, punctuality percentage on the y-axis over there. In terms of the values, I can put the TLC name in terms of, and the values bit here. I can put the TLC name. As you can see, it's starting to show some sort of pattern on there. In terms of the size, for instance, I might say I want to use the average delay. I might say average delay 2 minutes to plot the size. And if I throw that in there, you can kind of see. So again, as this changes, you'll be able to see sort of different bubbles again of circuits that kind of tell you what is with services, right? So okay, so again, we're looking at some sort of operator comparisons that allows you to understand what's going on with the service. So if I put this on there, I can just see, okay, on the tooltip tells me Northern 4,136 services, punctuality percentage 32.37, average delay minutes 2.84. Okay, again, this is not representative of what your values. I'm sure Northern is doing far better than that. But again, this sort of shows you the sort of things that you can achieve within Power BI, making these sort of visualizations and insights. Okay, all right. Next, let's have a quick look at, say, geographic performance analysis. So for geographic performance analysis, let's go into our regional performance tab here. And what we can do is we can just create a table for now.
On this, how we would create a table, would go there, select the table icon, and we would have our station name and the rows, and have our station name there. Or let's also have our total services, top columns, and then
Total services to the table.
so let's start a little bit, and let's add some punctuality percentage as well. We could also add the average delay minutes as well over there. And we could come over here again, effects, put the visual comment in there, and put a title. In the title there, I will call this Station Performance Summary. Okay, I can have that set, so say the middle. I can put it in bold. I can put an underline on it there. Change font to perhaps single UI bold. I can amend the color there, the something let's import a little bit, and I can have this table like so. So yeah, that's how you'd make a very, very simple table in Power BI. The other thing we might want to look at here again is looking at things like delay attribution.
Perhaps might want to do some basic root cause analysis. Okay. Again, we can capture some more measures. We'll call those measure total delay minutes, and that is just a sum. Tab to accept it, and we can get the
minutes late column, and we'll accept that. Okay, we'll make another measure. This time we want to create a measure for just primary delays. We just Alt Enter to go onto a new line. We want to make a calculation of our total delay minutes, but pre-calculated already in the previous measure. And we also want to connect it on the basis of delay attributions, where the delay type is considered primary. Okay, and close that. We create another measure, and we call this measure reactionary delays,
and we want to capture total delay minutes
relative to delay attribution, where the delay type is reactionary in quotation marks, so where I would say text, and we close that as well. We then create one more measure. So you see, measures are very, very powerful things that we can use when we are trying to gather insights from our data. So we're going to call this the delay attribution rate, and the delay attribution rate is a division where the numerator is the
total delay minutes that we calculated,
and we want to do that relative to all of the services. Okay, else just return a 0. Nice and simple. Okay, so
we have those measures. What we then do is we can create a new page, and let's call this page delay cause.
Delay cause analysis, hit enter, accept that, and here we can create a very simple pie chart, or perhaps a donut chart if you like. We create a simple pie chart, and we want to put the total delay minutes that we calculated in the values. In the legend, we want to go to the delay attribution, where we want to select the cause category. So delay attribution category will be, well, the legend, like so. Just that a little bit. So let's see the visual. And again, we can come here. We've brought our general tab. We can add the title there, where it says total delay minute by category. Well, you leave that, I put it out. That makes sense. Happy days. I like to put it up. The digital border, leave it without a shadow for now. And then next we can also add a waterfall chart. Okay, and then that is a waterfall chart over there. Just gonna bring this over here. And waterfall chart, we want to have the course category, okay, as the category over there. Total minutes, y-axis, and this just basically shows us cumulative impact, so different delay causes. All right, so we can throw that in there. Of course, if you selected any of these, for instance, where it says signal, for instance, and we selected that, yeah, align with what you have on the pie chart to the left. Or hit that again, it releases that visualization and so forth. Having done these, we could also create a matrix. Okay. So we can create a matrix visualization. Just going to select the matrix visualization there, and in the rows we are going to go to our, and we're going to put in the day of the week. Okay, so the week in our rows, and in the columns we're going to put the causal category. Okay, so causal category. So this is a classic issue that can come up when you're working with data operationally, where basically you have fields and a visualization from two different tables here with no clear path between. Of course, that just means that there is ambiguity there in what we're trying to relate. As we can see here, the pie charts, the waterfall chart themselves, we're using tables that actually have a connection between. Here, we are mixing a relationship between our date dimension and taking the day of the week there and trying to connect it with the cause category, which is a delay attribution facts table. So the issue here is that Power BI cannot find an unambiguous relationship pathway, so it throws this out. So if you ever see this in a visualization, can't determine relationships within the fields, and that's the idea. It does say fix this over here. I would not recommend that you did that, because when you say fix this over here, what Power BI then does is it automatically, or very often, it would create a bi-direction, relationship, or off-direction relationship, which is also ambiguous. That can cause you issues later on. When you're doing many-to-many relationships without having what is called a bridge, then it does make the flow of the filtering to be unpredictable, because there is no semantic relationship. There's no set semantic relationship between one table and the other. So in this sort of situation, we would do or create what is called a bridge, and we can do this with a DAX measure. This is why DAX is so powerful. But we're going to be doing something interesting here, because we're going to be creating a new table. We're going to be creating a new table using DAX measure. So we come over to the table view. Remember, that's our report view, that's our table view, and that's our model view. So we'll go to the table view, and we're going to create a new table. So again, we'll go on to, oh no, we can't do that. I was thinking perhaps we could do it from the model view. We just want to create a new table that we're going to add to the model, but using DAX measure. So this is how we're going to do that. In the table view here, we hit new table, and as you can see, our equation bar gets activated. So we're going to call this a service dimension. Let's call it a service Y, because we're going to add columns. Very easy to create a table. We're going to add columns. And for that add columns, and just put it on a line down here. So let's start what we're doing. So we're adding columns where we want to get the stop calls, service ID, and we want to capture service date. So the service ID, matching it with the service date. And then we then say we want to also calculate the minimum value of stop calls, service dates. Yeah, we'll just have it as that. And 1, 2, and 3. Yes, capture that service date. So what happens? Once we have captured the service ID from the stop calls and we've mapped it to a service date right from the top of the dates all the way through. We've got 33,591 rows. Okay. All right. So again, that's a quick visual way that we can use to sense check against what we are building. So if we go to our stop calls, as you can see, we also have 33,591 rows. Created this service dimension. Now we're going to then create single dimensions in the model view. Now, the best practice when you're creating dimensions is that you always go from a dimension to a fact. From a dimension to a fact. What we have now created this service dimension here is that we have created a fact table. Okay. We are going to be taking the date to service date. We're going to take the date, so that's what we're going to be doing here. So we'll take this dimension and we'll plunk it onto that, and as you can see, we have a one-to-many relationship, which is what we want. Fantastic. So that dimension there is giving our facts table some context. Rearrangement here, just to get things looking tidy. Fantastic. So I can see that direct line between the two of them and still maintain this relationships. Now I want to then take the service dim, service ID. Now this is the bridging that we're talking about. I'm now going to take this service dimension, service ID, and then I'm going to connect it to the service ID on the stop calls. So I'll now go service ID from this dimension, this bridge table that I've created, to then connect to the service ID on the facts. Service dim, taking service ID to stop calls or service ID to one-to-many. I want a one-to-many relationship from the service ID and the service dim to the stop calls service ID. And I'm going to save that. I then want to take the service ID from the service dim again, and this time I want to connect it to the service ID on the delay attribute. So this is what we're talking about, data modeling. I'm going to take the service ID from here and I'm going to create a connection to the service ID in the delay attribute. Also, I want this to be a one-to-many. Fantastic. And I'm going to make this relationship active, but it says the ambiguous path if I make it active. So it's just going to be a reference point. So I'm just going to say save and voila. Okay, so once we've now gotten all of that ready, save your work there, and let's come back to this. And oh wow, fantastic. As you can see, that's now giving us some outputs. So we've created the bridge, and this is giving us some output here. So we've got causal category as columns. Let's go for total delay minutes as the value. So take the total delay minutes and pop it in there for the value, and just like that, I'm just going to go to the limits of the real estate that I have here. We can create that view like so. So we now have this. We can go over here. General, I can put the title on, I can put the border on, and the shadow, and just add a title to that. I'll call these delay patterns by day of week. We can kind of see based on the day of the week what the delay patterns are like. Fantastic. Having done that, we now have all of that information to go by. Again, we can proceed to do some more advanced analytics and look at even getting more insight from data.